x equals 1, right? So initially it was at x equals 1. If I say this is 1, and it was at x equals 1 till when? 2 seconds. For 2 seconds it is at the same position. Direction x equals 2 at a constant. Okay, so for 2 to 3 seconds it's moving to the position x equals 2 meter, right? So this will be the graph of variation of position with time. We analyzed already. Now look at this question, students. Refer to the graph on right this. Where is the velocity positive and constant? Where is the velocity positive and constant? So if you look at A, velocity is positive and constant. It's a straight line, right? So one position is A. We are going to keep removing this. And what about B? At B, velocity is not constant. At F, velocity is constant, and also at G, velocity is constant. So we can write F and G also. Now look for B. When is the object at rest? When velocity will be 0, object will be at rest. And from the different position time graph, speed or velocity you can get for looking for the slope. So for B, when is the object at rest? Look for the position where velocity is 0. Object is at rest at position 2, right? Position E. Because at that position slope is 0, so velocity is 0. Go for C. Where is the instantaneous speed greatest? Instantaneous speed greatest, that means look for the slope. F and G both have the same speed, right? Even same velocity, and also the slope is greatest. So we can take F and G as the answer. Now, okay, so if you look for where is the velocity positive and constant, so velocity is positive at A and constant. For F and G, it's negative, so it's not our answer. Velocity is negative at F and G. Where is speed undefined? At D, it's undefined. We cannot find out the slope at D. D has the sharp corner, right? Look for E. Where is acceleration? 0. When speed is constant, acceleration is 0. So A, F, G, also E. When particle is at rest, then speed is 0, also acceleration is 0, right? You'll see. So we got the answers. Let's go for this question. For the graph on the right, find total displacement. For total displacement, what we do, we look for the initial position, that is 0, and look for the final position, that is 20. So displacement delta x will be 20 minus 0, that will be 20 meters. Now go for the B, the velocity at t equals 1 second. T equals 1 second is somewhere here, and for 0 to 2 seconds, velocity will be constant, right? So we can take the slope, that will be 40 over velocity change in position over change in time. So 40 over, we can take this right? So 40 over 2, we got 20 meter per second. Velocity at t equals 8 seconds. So t equals 8 seconds is somewhere here, and to find out the slope we need to look for this slope. So for C, v will be minus, if we are going to subtract, it will be 20 minus 40, that will means minus 20 over, this time interval is, this is something 5 and this is 10, so minus 10 minus 5 is 5, so minus 4 meter per second is the speed. Yeah, we can see it's the velocity is negative here, slope is negative. Go for D, the average acceleration for t equals 5 to 9. If we look for 5 to 9, there is, throughout the motion, velocity is constant, 5 to 9, right? So acceleration will be 0. A average will be 0. Now let's come to another question. We have to analyze velocity time graph for this situation. So students, see, for this, if I say this is T1, this is T2, this is T3, this is T4, and this is T6. T6. So now look, 0 to T1, velocity is uniformly increasing. 0 to T1, velocity is uniformly increasing. That means it's the case of uniform acceleration, and its slope will give us acceleration. Its slope will give us acceleration. 0 to T1, velocity is uniformly increasing. V uniformly increasing. If you look for T1 to T2, V is constant. That means acceleration is 0. T1 to T2, V is constant. T2 to T3, even we can say T2 to T5, velocity T2 to T3 is decreasing, and T3 to T5 also decreasing. If you are talking about speed, first T2 to T3 speed is decreasing and becoming 0, then it's increasing and going to some maximum value. T5 to T6, again velocity uniformly increasing. So it's the case of uniform acceleration. We can take this example, Let's bind up it here. Students, if we talk, let's take this question. Analyze acceleration versus time graphs. Here acceleration for 0 to 2 seconds is constant. So 0 to 2 seconds we have a uniform accelerated motion. 2 to 4 second, if you look 2 to 4 second, acceleration is 0. So it's the case of 2 to 4 second is the case of constant velocity motion. For 4 to 6 seconds, if you look, we have the negative acceleration. That means it's a accelerated motion and acceleration is negative. I hope you understand the questions and concepts, and you will be able to get a better score. If you want classes online live with me, you can join me. We can have the live sessions. Thank you.